Hello everyone, welcome to the 7th tutorial session of Problem Solving to Programming in C. This is a SWAYAM course that has been floated by Professor Anupam Basu from Department of CSC, IIT Kharagpur. And I'm Siddhant. I'm one of the 3 TAs who will be taking these tutorial classes to help you with the questions, assignment questions from the previous years, so that you can solve the current assignment questions, and it will also help you out with the final exams. Alright, so in week 8, the lectures covered were related to functions and especially recursions, and we also saw a few widely used functions like printf and scanf. So in this session, we will be solving a few questions based on the same. So let us start this session. So uh, I have a question for you regarding a simple function, which is so the first question is basically we have a function called fun, and it prints hi. Why do you think it's a compilation error? Okay. Initially we are declaring the variables and functions. I didn't. So you are defining the function prototype here, right? So this is fine. There is no issue here. This you are defining. There is a global variable that you are defining. This is also fine. There is no issues with this one as well. So I here is a global variable which you have defined outside all functions. That means it's global to the entire code. All functions can access this variable. And then you have the function called fun, which is you have defined the function prototype initially, because you have two options. Either you can define a function prototype and use the function later on, you can write the function after the main function, or you have to define the function called fun before the main function. In that case, you don't need to write the function prototype. So those are the two ways that you could have done this. So in this case, you have the function prototype that has been mentioned here before the main function, and you can see that this function called fun, this prints hi. Okay. And in the main function, you have a while loop which checks the value of I, basically, which depends on the value of I. And inside the function you have a function call of the fun function and the main function. So, and after the while loop you are printing hello and then returning 0. So how many times should hi be printed in this program? So basically, this is a global variable of integer. Okay, I mean zero times. Okay, that is correct. Because here I is a global variable of integer type, and whenever we define a global variable of integer type, the compiler automatically sets the value of the integer type unless it has been declared. The value has been initialized. It will set it to 0. So when we in the main function, when we access this I, which, as you can see, in the main function there is no variable I that has been defined. So when I write I here, this refers to the global variable, that is I. So the global variable, as you can see, has a value of 0 because it was automatically initialized to 0 by the compiler. And so basically we are writing while of 0, and while of 0 means it will not run because it's false. The condition that should be satisfied for the while loop to run, that is false. So this the while loop will not run. And the output from this program will be simply hello, and there will be no hi that will be printed. So hi is not going to be printed in this particular snippet. So 0 times. Is that clear? All right. So now another question, especially to highlight the importance of global scope, the scope of the variables, that is the global scope versus the local scope of a variable. So you can check this out. So you have another global variable that has been defined. So this is a global variable, and as you can see, this is again eh, okay, okay. All right, we'll see what the answer is. So we have again the function prototype, and then we are defining a variable j which equals I. So j here is a local variable, so this is a local variable, okay, and it is local to the main function. Right, now we are setting the value of j to the value of I. Here I, there is, as you can see, there is no I that has been defined prior to this to this statement inside the main function. So this I will basically refer to the global variable I, that is having the value of 15. So here we will set j equals 15, and then we write I is equal to the function fun. So we call the function fun, and what about this I? So still we have not declared any I variable inside the main function, so this still refers to the global variable I. Okay, um, and what when we call the fun function, what happens? We define some int I. This is local to the function fun. So this I variable that you have defined, this is a local variable which is having a function which is local to the function called fun. And whenever you are inside a particular whenever there is a conflict between local and global variable, I mean, for example, here you are supposed to return I, and you can see that there is a local variable I and there is a global variable I. So in that case, the local variable will always have a greater priority than a global variable, right? So here the I that will be returned will carry a value of 25. Okay, and you are returning this value, and you are storing this value in the global variable I, because that is what this main function basically, in the main function, this statement basically means. So this fun returns a value of 25, uh, which has been returned from the function fun, and that is being stored in the global variable I. And then we print, so here basically we are storing I as 25. Now we print I and j, which is basically we are printing 25 comma 15, because j we set it at 15, I we set it at 25. 25, this still refers to the global variable I, because as you can see, no variable called I has been defined inside the main function, so this still refers to the global variable. So this here the answer will be option B, which is 25 comma 15. Is everyone clear regarding the scope of the variable, that is the local scope versus the global scope? All right, so I assume it's clear to you, and we'll move on to the next question. So this can be a bit involved, so let's see what exactly this question asks us. So we have a function called get, and as you can see, the function has been defined in the way, this is a question of recursion, and the point where the recursion will break is when our n, which is the argument to the function, which is the parameter that is being passed to the function get, becomes less than 1. Then the function simply returns. That means the function call ends. Else, if this return statement does not happen, so whenever the return statement is called, the function stops there itself. right? Now if this condition is not satisfied, that is n is greater than equal to 1, um, you happen to get this function calls, which is get n minus 1 and get n minus 3. So now if we call get 6 and pass this n equal to 6 here, so what do you think, how many times should the will the get function be invoked? You have to calculate this very carefully. So can you try this out? So the way to proceed here would be, just maybe make a flowchart or something. So let's say it's get of 6, and now 6 is greater than 1, so it will not greater than equal to 1, so it will not return definitely. Now I write get of 5, so it will call a get of 5, right? Now I'll follow get of 5. What happens is get of 4. Get of 4 will call get of 3. Get of 3 will call get of 2. Okay, so what, okay, yeah. So this get of 3 will call get of 2, and so currently I'm just going in the n minus 1 route. Okay, now get of so now the get of 2 will call get of 1, get of 1 will call get of 0, and get of 0, as you can see, it will return, right? So get of 0, when you go to get of 0, so now 0 is less than 1, so it will simply return. So I'll just use another ink for this, maybe that will be a bit easier to understand. So this basically you get returned back to this. All right, now when you return back to this, so for the get 1, when get 1 was invoked, so get 0 was one thing that got involved, that is the n minus 1, but there is also supposed to be n minus 3 that is supposed to be invoked. So this also invoked get of minus 2, that is 1 minus 3, that is minus 2, right? So get of minus 2, but get of minus 2, as you can see, it is again less than 1, so it will just return back to this. All right, now the same will happen for get of 2. So what happens for get of 2? Get of when it returns back here, and this get of 1, so this get of 1 returns back to get of 2. So the other thing that will be called here is get of 2 minus 3, that is minus 1, right? Now both of this, so both of this will get returned back here, this will get returned back here, right? And all right, so what happens after that? So this get of 2 is done. Now get of 2 will return back to get of 3. And what else will get of 3? I mean, when get of 3 was called, it will call get of 2, which is n minus 1, and the other thing that it will call is get of 0, right? Because 3 minus n minus 3, that is 3 minus 3, that is 0. But as you can see, get of 0 is again 0 is less than 1, so it will simply return back here, right? Now what else you have? You have get of 3, now it is returning back, and here you will have get of 1 again, right? Because 4 minus 3, which is get of 1. I'll talk about the return part once I finish this entire flowchart. So now get of 4 will return back to get of 5. The other thing that will be called, that is following get of 4, which is n minus 1, for the get of 5 loop will be get of n minus 1, that is 5 minus 1, 5 minus 3, which is get of 2. So okay, yeah, I don't think there is an issue with my internet connection, so ideally it should be fine. Is it fine for the others? Are the others able to hear me? Okay, maybe I'll continue. Maybe the internet will get better. Okay. So here with get of 5, when get of 5 was called, we'll have get of 4, which is n minus 1, and get of 2, which is n minus 3. And again, at get of 6, what had been called? Get of 5 had been called because that was n minus 1. Now we would also have get of n minus 3, that is get of 3. Now again, this would have its own it would have its own flowchart under it. So I'm just not writing that. For example, this will go into get of 0 and it will return it again. So here this will return it back, and this is going to return here, this is going to return here, this is going to return here, and then again you have the get of 2, this will call get of 1, and this also, this will call get of 0, right? And this will call get of minus 1, and so on, like it will continue like that, right? And this will return back here, this will return back here, this will return back here. So finally we have to count the number of times the get function has been invoked. So let us count that. So here let us first count how many functions are how many times it is getting invoked when get of 3 is getting invoked. Let us count that. So we have 1, 2, 3, 4, 5, 6. So 6 times. So when we are invoking get of 3, uh, 6 times the get function is getting invoked after that. So, and how many times is get of 5? When you are calling get of 5, how many times is the get function getting invoked apart from the 3 one? So 1, 2, 3, 4, 5, 6, 7, right? And 8, considering this. So you have, so let me write that down again as well. So this is 1, 2, and I didn't count this earlier, so 3, 4, 5, 6, 7, 8, right? Is that correct? Yeah. So you have 8 times here plus 6 times under get of 3, which we counted before. And again, this under this get of 3, you will have 6 invocations, right? So 6, and what else? I have not still counted this 3, so 3 more. So what does that make it to be? Did we miss anything? Okay, I'll just check this again. So we have get of 6, which goes into get of 3, get of 5, get of 5 which goes into get of 2 and get of 4, get of 4 which goes into get of 1 and get of 3, and get of 3 which goes into get of 0 and get of 2, get of 2 which goes into get of minus 1 and 1, get of 1 which goes into minus 2 and 0, right? The flowchart is fine, so we just need to calculate what happens, I mean how many times it is getting invoked for get of 3, which is coming again here, and for get of 5, and then we can calculate the overall one, right? So for get of 3, it is getting called once, twice, thrice, 4 times, 5 times, 6 times, right? So for get of 3, under get of 3, it is getting called 6 times. Now let me just erase this one, we'll calculate fresh. Okay, and let us calculate from the top what is what is happening with the get of 5. So 1, 2, 3, 4, 5. Okay, just a moment. 1, 2, 3, 4, and 5, 6, 7. I think that's fine. 7, and 8 considering this. I think I'll have to repeat this because I can understand it has become a bit messy and you might not be able to see this. Maybe, yeah, just a moment. So, alright. So we had get of 4 here, and apart from 4 we had a get of 2, and here we had a get of 4, so get of 3 and get of 1. So get of 1 led to get of 0, and okay, we have missed another one here. So get of when we do it, it will be get of -2 as well, right? And similarly here again get of -2 whenever you are calling get of 1, because until it goes to a value less than 1 it is not going to return. So yeah, two more. So how many under the get of, so under get of 3 you had 6 invocations, right? Under get of 4 how many invocations do you have? So this 6 plus 1 7 8 9 10, so 10 invocations under get of 4. Now what about under get of 5? Under get of 5 11 12 13 14 15 16, 16 invocations under get of 5. And so we have 16 plus, then you have 6 invocations under get of 3, which is plus 6, and get of 3 get of 5 and get of 6, which is 25 basically. So under, if I have to write this, under get of 3 you have 6 invocations. If I calculate under get of 4 you have 10, I think. So 6 7 8 9 10, yes, so 10 invocations. Under get of 5 you have 11 12 13 14 15 16, so 16 invocations under get of 5, right? And under 3 again you have 6 invocations, so 16 plus 6, which is 22. And apart from that, get of 5 get of 3 and get of 6, which is 3 more, so total of 25 times. So the answer here is 25. Is that clear? I mean, it's a bit complicated, but once you get used to it, you'll understand. Alright, just go back and look into this, and if you have any doubts, you can ask in the next class. Okay. Alright, so let's move on to the next question. Here we have basically a function where we are calculating a sum over a nested for loop. So we are calling the function with the argument of value 5. So can you just quickly calculate what the return from this function will be, and the return itself will be printed from the return value from the function will be printed here. So what will be the return value for this function when we pass this n as 5? Can you just calculate that? So when we pass n as 5 and the for loop goes from 1 to n, so initially the sum is 0, as it has been initialized to 0, and when I is equal to 1, and j, as you can see, it goes only for a single loop, which is j is equal to I, j less than equal to I, that means it will run only for a single loop for any of the cases, any of the values of I. So when I is equal to 1, you have j is equal to 1, that's the only loop, and the sum will get incremented by j, which is 0 plus 1, it will become 1. Now you will have I of 2, j of 2, sum will be incremented by 2, which is 1 plus 2, that is 3. Then you have I is equal to 3, j is equal to 3, sum will get incremented by 3, which is 6. And I equal to 4, j equal to 4, sum will become 6 plus 4, 4, which is 10, right? Right. Then you have, as you can see, less than equal to n, so I equal to 5, j equal to 5, sum is equal to 10 plus 5, which is 15. Yeah. So this is the value that will be returned from this function, and this will be option C will be the answer. This is quite straightforward how the calculation is happening. All right. Okay. So let's look at the next question. So this is again another question related to the recursion. So let's again try to solve this question in the same way that we did for the previous one. So there is a function f which takes these two arguments n and k, and we are passing these two arguments, which is 20 and 1 initially, and it will recursively solve it. The condition for the breaking of the recursion is this, where it returns 0. At that point the function will start coming back to its the callback will happen. I mean, the return value will happen. The returning of the value will start happening once this condition is satisfied. So let's see what happens here. Initially we have 20 comma 1 that is being sent to the function. So the condition, so definitely n is not 0, so the first condition is not satisfied. The second condition is n percentage 2. So what is n percentage 2? So 20 percentage 2, how much is that? That is 0. So if of 0 means it's false, so the else part will be executed. So this second part will be executed, which is return f of n by 2. N by 2 is, n is an integer, so n by 2 is 10, and twice of k was 1 here, so twice of k is 2 minus 1. So the function has been recursively called. Now in this, what happens? So 10 percentage 2, what is that? That's 0 again. So again the second part will be executed, the else part will be executed, which is f of 5 comma 4 minus 2, because k is, for this function k is 2 now and n is 10. So now what happens here? You have 5 percentage 2, which is, now it is non-zero, so the first part will be executed. So you have 5 by 2, which is, because it's an integer, so only the integer part will be there. So 2 comma k was 4, so now it is 8, and it is plus 8, sorry, it was plus 4, right? Now this again calls 2 percentage 2, which is 0 again, so the else part will be executed. So f of 1 comma k was 8 for this particular function, so 16 minus 8, right? Then 1 percentage 2, which is 1, so the else if condition is going to be executed. So 1 by 2, which is 0, and 2 into k, which is 16 here, so 32 plus 16, right? And as you can see here, n has become 0 now, so the return value for this will be, so this part will be 0, because that is what the breaking condition for this recursion is. So n equal to 0, so then return 0. So n became 0, it returns 0 here, so this became 16. Now this 16 gets returned back here, which is now 16 minus 8, which is 8. Now this 8 gets returned back here, 8 plus 4, which is 12. 12 gets returned back here. 12 minus 2, 10. 10 gets returned here. 10 minus 1, which is 9. And that is what gets returns back here. So basically here we will have the value of 9. Is that clear how this recursion happens? Okay. Alright, so next let's check the next question then. So here you have the right shift operation. So what that does is it shifts the binary digits to the right by one place. Now we'll do an example as well. So right. So what happens here, we are counting the number of times a certain binary value can be shifted by one place at a time to the right before the value becomes 0. That's what we are counting here. So our value that has been passed is 435. So you can actually calculate the binary equivalent of 435. So it's 217, remainder of 1. Have 108 with remainder of 1. 54 with remainder 0. 27 remainder 0. 13 with remainder 1. 6 with remainder 1. 3 with remainder 0. 1 with remainder 1. 0 with remainder 1, and we take it to the back. So 435 of 10 in best 10 will be 1 1 0 1 1 0 0 1 1. Okay, now when you shift this 435 by 1, so this is 1, what happens, it basically becomes 0 1 1 0 1 1 0 0 1. This is what happens, and if you recalculate this, you will get 217. So it is quite similar to what has been written here, where if you take 60, then if you shift it by 1, you will have 30, and that happens in every step again and again. So here the count already became 1, and what happens, so count becomes 1 when the value was 0 the value was 1 1 0 1 1 0 0 1 1. So the count already became 1. Now in the next step, what happens, it is still greater than 0. 217 is greater than 0, so the value is 0 1 1 0 1 1 0 0 1, right? And this became 2, and what will happen when we right shift this, you will have 0 0 1 1 0 1 1 0 0, right? And this value is actually 108, so the count became 3. So basically what we are counting until we get this 0 value here. So how many steps till we get the 0 value? We start from 435. This is where the count value increased by 1 for the first time. So before it reaches 0, how many count increments occurred? So we have one increment here, 1 2 3 4 5 6 7 8 and 9. So why I'm not counting the last one? Because after it became 0, then the count did not increase anymore, because that's where the while loop stopped working. The while loop was working when the value was 435, so that is where the condition was satisfied. But once the value became 0, after in the next iteration, there was the condition itself became false and the while loop did not work anymore. So there is a total of 9 iterations, or 9 hence it took 9 iterations before the num value became 0. So that is what the count is calculating. So the answer here will be 9. So 9 will be the value that is returned. Yes, do you have any questions? Yeah, if you have any questions, you can either write in the chat box or you can unmute and ask. Okay, all right. So let's move on to the next question. So here we have again the scope. Yeah, I mean the base is required because otherwise it's I mean just to denote that it's a binary. It's not necessary to write it because you'll understand it's in one and zeros, so it is a binary. But I've just written it just to be proper. I've written it along with the base. Yeah. Okay. So here we have again the scope of the variable. So what do you think if you run this particular code on the left side of the screen? What should you get as an as output? So you can see that the int a is equal to 70 has been defined within this two curly braces. So this is the scope of the variable a. Okay. So because this is the scope of the variable a, the variable a here is not defined because the scope of the variable a was only limited to within this first set of curly braces, right? So when we try to print the a within using this printf statement inside this another block of another curly braces, another set of statements or block of statements, a is not actually defined here because we have already exited the first set of curly braces. So outside those curly braces, the variable a does not exist, and we are trying to print the value of the variable a, which actually does not exist. So you will get a compilation error here saying that the variable has not been defined. All right, is that clear? So basically the scope of a variable can not just be local to a function, but it can be local to a set of statements as well. All right, I hope that's clear. So we'll move on to the next question. So here basically it's a pretty straightforward question where we have this array, just age, which consists of 6 different values of floating point type, and you are passing this array to a function called func, and inside the func it is calculating a sum over all the elements of the array and dividing it by 6. So and it is returning the result to the main function. So what should be the answer here? Can you just quickly calculate this? This is so when it passes the array and you have sum set initialized to 0.0, and the for loop goes from 0 till 5 because less than 6, so it is going till 5, and it basically the variable sum adds up the all the elements of the array age. So a of 0, which is 23.4, so sum becomes, when I is equal to 0, sum becomes 0 plus 23.4, that is 23.4. I becomes 1, sum becomes 23.4 plus 55, which is 78.4, right? and so on. So you have I2, I3, I4 up till I5. So you get some value of sum. Then you divide that sum. The variable result is actually the sum divided by 6, right? And you'll get some 27.083333 and so on. So this is the result that is going to be passed uh, or going to be returned to this particular statement where the function has been called. And when you try to print it, you can see that you have used a uh, very particular format specifier, which is %.02. That means only 2 digits after the decimal will be printed in case of floating point. So this you get 27.08 as the answer. Option A will be the answer. Okay. Alright, so if that's clear, then we'll move on to the next question. So we have a code where you have defined a character variable which is x, which equals 0, and we go in a for loop from x having 0 till 127 with increments of 1, and you print x as an integer because %t, that refers to an integer. So what will be the output of this particular code? Option B. Okay. All right. So what happens here is that it's a very special characteristic of the character of char. Uh, okay. When you define char like this, it basically means it is a signed char. Now, what does signed char mean? Signed char basically exists. Signed char can take values from -128 to +127. Okay. So why signed? Because it can take negative data as well, that is -128 to -1. So there is a leftmost bit left for the negative sign. So if it is negative, it is 1, and if it is positive, then it's 0. This is the leftmost bit. All right. Now there is another char called unsigned char. That means it cannot hold any negative values. So you'll have values from 0 to 255. Okay. Now what happens when you define a signed char with a value more than 127? So you can definitely give it a integer value of more than 127. What happens in that case? So it will just wrap through. So basically you have, if you set char x is equal to 128, it can till 127 we know that there are this characters. So if you set it to 128 and you try to print %t x, so x automatically has become minus of 128 because it wraps through to the end of the signed char. So 128 is basically minus 128. 129 is basically minus 127. So if I write 128, that gets changed to minus 128. If I write 129, it gets changed to minus 127. 130 minus 126, and so on. So as you can see what happens here. So when x becomes 128, I mean from 0 to 127 it is going to get printed. That's pretty clear. What happens when after the end of the loop where x is 127, the increment occurs to 128, the x value actually becomes minus 128 because like I said, char has this wrapping characteristic. So minus 128, it becomes, the 128 becomes minus 128. So the x value still satisfies this condition, which is it should be less than minus 1, less than equal to 127. It still satisfies that because it is minus 128, right? So you have minus 128 getting printed. Now you increment x by 1, it becomes minus 127. So minus 127 gets printed. So again, it keeps on printing all the way till 0, till 127, and again the value becomes 128. So the value changes to minus 128. So this keeps on continuing infinitely. So that is why here the answer would be option C. It says it keeps printing 0 to 127, then minus 128, minus 127, and so on, and it repeats the same thing, repeats again and again. Is that clear? No? Okay. Uh, okay. So did you understand what the sign jar, how this wrapping occurs? So okay, why in the for loop part? Okay. So you understand why it should print from 0 to 127, right? So let's say I was 127 and you got the output 127. Now it incremented, right? I plus plus. So it became 128. Sorry, not I, but x. So you did x plus plus. That basically means that you did. So when you did x plus plus, what happened is you tried to save x equal to 128. But because of this characteristic of the char, it cannot save values more than 127. So what it does is it wraps it back to the values that it can. So it is something like this. So it minus 128, the range goes on like, then it comes back here, right? After this. So this basically becomes minus 128. Now minus 128 satisfies the condition because it's less than equal to 127. So it is still satisfying the condition, and again increment and continue. So it is going to be an infinite loop. It will go on infinitely like this, like printing 0 to 127, then minus 128 to 127, then again minus 128 to 127, and so on. Okay, all right. So if that is clear, we can look at the next question, which is a function which is find. It takes two arguments, x and y, and it returns this ternary, whatever the output is from this ternary operation. So if uh, say a and b are two non-negative integers, so they are non-negative, that means 0 or more, so it's a whole number, and you call this find a of b of a comma b. So what exactly would it return? So you can actually write the overall ternary expression for this. So first let us write this a comma b, which is a less than b, this 0, a minus b. So this is the inner ternary operation. Now there will be an outer ternary operation, which is basically a and whatever this value we get from here. So I'll just put this in braces. So a less than this, right? 0, right? And x minus y, which is this minus this. So whatever we get from this minus this. So right, this is, we can write it like this, but as you can see it becomes a bit more complicated when you write it like this. So if with questions like this, you know that it is non-negative, so you can take anything greater than equal to 0. So just take any two numbers and try to find out. So that is the easiest way to solve this kind of questions. So let us take AB is equal to some 5 and 10. Okay, so we'll take it to two different combinations, so that once we'll take 5 comma 10, once we'll take 10 comma 5. Okay, now let's take 5 comma 10. So what happens in that case? What is find 5 comma 10? Find 5 comma 10. 5 is less than 10. No, it should be fine, but because there are this parenthesis that you have given here, so you can have a ternary operation within that, because whenever you're trying to return, before the return takes place, this evaluation will take place, because the parenthesis has highest priority. So it will evaluate first and then it will return. Okay. So find 5 less than 10. So this is basically what it is supposed to return, right? So 5 is less than 10, so it will return 0, right? So now 0 is returned here, right? And once 0 is returned, we check it again with 5 comma 0, right? So 5 is less than 0, then return 0 or return this. So this time it's false, so this it is going to return this one, right? So it is going to return 5. So for this case, this returns 5. What about this? So alright, I can see why you are facing this issue. Let me take some other value, say 15 comma 12. Okay, so when I take 15 comma 12, what should I get? So find 15 comma 12. What will be the return value here? 15 is less than 12, it's false. So 15 minus 12, you get 3 here as the return value, and then you do a find 15 comma 3, right? Now what will be the return value here? Again it will be false. So 15 minus 3, which is 12, right? Is it clear? Are you able to understand what I'm trying to write here? So here I took another example 15 comma 12, where if you run this find 15 comma 12, 15 less than 12, which is false, so then the uh, part after the colon will be executed, which is 15 minus 12, which is 3. Now the value is 3 from this, so we do again a find 15 comma 3, and again 15 less than 3, it is false again, so it will again do the colon part, which is 15 minus 3, 12. So the answer basically from here is 12. So you can take another example if you want, but I think we know more or less which among these options should be the correct one. So it should be the minimum of A and B. Or you can take another example, like some very high value. So 100 comma maybe 150 or something, right? You can take that, you can still do that. So find of 100 comma 150, how much will that be? This will be 0, because 100 is less than 150, so the first part, and then we do 100 comma 0, second part. So 100 minus 0, 100, so this gives a value of 100. So in all these cases you can see that it is pointing towards the lower value that we have among A and B. So that is what is the answer here. That is the best possible option. All right. Okay. So if that is clear, let's move on to the next question, which is printing hello world, where we started, where everything started from. So we are printing hello world, but we are doing another thing, which is we are calling the main function again inside the main function. So recursively we are calling the main function. So how many times will hello world be printed? So whenever you do a function call, the functions are getting stored in something called a stack. So what is a stack? A stack is basically a kind of a data structure where, think of like a memory location where you have lots of different levels and so on. So you put this main function here, you put this in. So every time a function is called, it keeps getting populated in the stack. So this is a LIFO kind of a data structure, which is basically a short form to say last in is the first out. So think about a stack of plates. So when you keep placing one plate on top of another, that is the way each plate is a main function. So when I call the main function first, and I recursively call the main function within it, so I keep stacking the main function on top of one another, and I can only access if I want to remove a particular main function, I can only remove from the top. I cannot remove it from the bottom. So that is what a stack basically means when it's a LIFO kind of a data structure where the last one, the most latest one that you have put in the stack, that is the first one to come out. So if you want to access some function which is in the middle of the stack, you have to remove the rest of the remove the rest of the stack above it so that you can access that particular function. So in this, that is just the explanation of what a stack is. So stack is basically a data structure, and whenever you have any program or any compiler, so depending on the processor and the programming language, you have a calling stack where which takes care of the function calls, and you can call the functions recursively until you fill up the stack. Once you fill up the stack, if you still recursively call functions, it will cause something which is called a stack overflow, and that is what will happen here, because ideally in a good recursive code you don't you have a condition for breaking the recursion, a condition in which when satisfied the recursion stops. But here, as you can see, there is no condition as such to break the recursion. So it will continue till the calling stack gets filled up and it causes an overflow. So you will have hello world being printed till that point. Okay, is that clear? If that is clear, then we'll see the last question for this. This is again another recursion based question, so we have to pay a little bit of attention to the solution. So here we have this function called func, which takes again two arguments, just n and sum, and then we calculate, we do a percentage 10 and we divide it by 10, and basically we add up the last digit of n to the sum, right? And we said we have a main function where we have a is equal to 2048, and we are passing, for the first one we are passing 2048 comma 0. Okay, so keep in mind that this is a function of void type, so it does not return any values. Okay, all right, so let's start solving this. So func 2048 comma 0, what happens there? N is not equal to 0, 2048 is not equal to 0, so return does not happen. Now alright, so we have k equal to, so we have k equals n percentage 10, which is 2048 percentage 10, that means 8, right? 204 is the quotient, 8 is the remainder, and we have j is equal to n by 10, and j is an integer, so you have 2048 by 10, just 204, and you call func again with j comma sum, and yeah, sorry, let me add up the sum as well. So the sum will become 0 plus k, which is 0 plus 8, right? The sum will become 8. Now we again call the function called func, and with j and sum, that is 204 comma 8, right? So what happens here? Now the k is equal to 204 percentage 10, which is 4. J is equal to 204 by 10, which is 20. Sum that has been passed here will be 8 plus 4, that is 12, right? And then we call function again. So with what? With j and sum, so 20 comma 12, right? So what happens here? We have k is equal to 20 percentage 10, which is 0. J equal to 20 by 10, which is 2. Sum is equal to 12 plus 0, which is 12, and again we call function, right, with 2 and 12. Okay, now again 2 percentage 10 is 2, right, and j equal to 2 by 10, which becomes 0 because it's an integer now. Sum is 12 plus 2, which is 14, right, and we call func again with 0 and 14. Now when we call func with 0 and 14, so n becomes 0 now, so it just returns from here. So the value just returns from here. I mean, there is no return value, the function returns from here, it's a void function. So this will basically, it will come back to itself. Alright, now alright, so when it comes back here, what happens after this? You have k getting printed. So what was k here? K was 2, so you have 2 getting printed. Alright, then this returns, this function gets over. Well, if we go back to this where this has been called, this function has been called, so this function had been called inside this 20 comma 12, and the k value was 0. So after the function call, the next statement was a print statement printing the value of k, and k was 0 here, so you get 0 being printed. Next you go, this function gets over, you go back to this function call, and inside this function call, this 20 comma, I mean, after printing this, it comes back to this, like it came back to this, it comes back to this, and after 20 comma 12, the function 20 comma 12, what was there? It was printing the value of k, and the value of k was 4, so 4 was printed. All right, Now then the function came back, and the flow of the program came back to here, and this part is now complete. So the next thing is to print the value of k, and the value of k was 8 here, so it prints 8. All right, now this is our initial function call, and we have reached our initial function call. But as you can see, uh, and we have printed 8 in our initial function call, we have printed 8. But as you can see, there is no return value for this function because it's a void type, so nothing gets returned to the main function. So when we print sum here, the sum value is still 0, so 0 gets printed. So answer is option D. Were you able to understand this? Okay. You can probably go back and try solving it by yourself. If you have any doubts, you can bring them to me in the next tutorial session. All right. So okay. Yeah. All right. So we'll discuss. If you have any doubts, we'll discuss that at the end of the class. Okay, so basically, the the program is to write to enter an integer and convert it to octal using recursion. So how do you convert an integer to octal? That's the first question. So we need to, any integer or any decimal, we have to divide it by 8 and find the remainder. The remainder can be from 0 till 7, right? So this value can be all this 0 to 7. So, and you need to add that up in a reverse manner, and in the reverse manner you saw that the octal is actually the recursion is pretty good for that. So every time, say the integer is n, you need to do a n percentage 8 in order to find the remainder, and you need the existing octal value to move by one digit to the I mean to increase by to multiply it by 10 so that you can add up the remainder there. And if you recurse that totally, so let me say this part, whatever is left should be the recursion part. It's a bit tricky to understand, so I'll just write the entire function maybe. So to octal int n. Okay, so yeah, I think this should be fine. So I'll write if n equals 0, then return 0. This is our break condition for the recursion. Else we return n percentage 8 plus 2 octal n by 8 into 10. Why n by 8? So what exactly happens here? So you enter number, any number, say 435. I do a percentage 8, so 435 percentage 8, and then the remaining number, that is 435 by 8, I pass it to octal. I pass it again, so this I had passed to octal, so now I pass this to octal, right? Now again, inside this it must have done 435 by 8 percentage 8, and then it would have passed it to octal, that is 435 by 8 by 8, okay, by 64 basically. So it passes to octal. So what happens here when finally this value becomes 0, that is where the return happens. And once it gets returned, say at this point it gets returned from here, that means you multiply that with 10 and add this remainder that you found. So when you saw that I converted it to binary, maybe I can just go back to that page. Yeah, so when I convert it to binary, it is quite similar actually. So you want it to be in the reverse order. So you take this reminder, you see where it becomes 0, that is where it starts returning all the values. The recursion starts calling back. So you take this value. So here I take this 1, I multiply it by 10, I add it with 1, this becomes 11, right? Now this 11, I multiply it with 10, add it with 0, it becomes 110. Then 110, multiply it with 0, add with 1, so it becomes 1101, right? Next again 1101, multiply with 10, add 1, so it becomes 110101. Sorry, 0, 11011, right? So this way if you keep continuing in the returning part of the function there, you will get this value 1101100011. So this is what you wanted to get, just that this is in binary, but that would be in octal. So this is basically the algorithm that we have to follow for the recursion. So this is, and you can write the code by yourself, I guess. So this is the algorithm basically that you need to follow so that any number can be converted to octal using recursion. Okay. Yeah. Now someone had some doubt in increment decrement operator. Can you please ask that? So this will be everything for this particular class. Those are all the questions I had for you today. So uh, we'll meet if you can just go through this. Recursion is a bit tough, I know, but if you work it out very carefully, you should be fine. So please go back and look at the solutions again. I'll upload the PDF and the lecture onto the website, I'll provide you the links in that Excel sheet, and you can go through the solutions again or try to solve them by yourselves and then look at the solutions so that you can understand how this recursion questions can be solved, right? Okay, so thank you for joining, and we'll see you next Tuesday, the same time, 7 to 9.